If you are ready to take your Python skills to the next level, then this video is for you. I'm going to show you 30 functions you need to know. The goal of this lesson is to make you write production-ready code while leveraging functions provided by Python. I assure you that by the end of this lesson, you will be on your way to becoming a better Python engineer. Without any delay, let's dive in. The first built-in function is enumerate. This function allows you to write a Pythonic loop without the need to manually keep track of the index of an item. Given an iterable such as a list, we can loop through the items in this list using enumerate. For index, item, enumerate of list, print, index, item. We are making use of f strings here. Let's run the program to see the output. We've been able to iterate the items in the list while retrieving the indices. Index represents the position of an item in an iterable. Optionally, we can pass an argument that specifies the first index it returns. Index of 1. This means the first item will have an index of 1. Let's run the program again to see the output. Fantastic. When I move the cursor over the function, the code editor shows what the function does. This is another way to know more about each function. The enumerate function returns an iterator, which is why you are able to use a for loop on it. As a matter of fact, each item in the iterator is returned as a tuple. Let's see this in action. For each in enumerate my list, print each. Let's run the program to see the output. Great, we can see that each item returned is a tuple. Sometimes you may have two or more iterables that you wish to combine. The zip function allows you to loop through multiple iterables in parallel. Each item returned by zip is a tuple containing elements from the provided iterables. Let's run the program to see the output. This shows each element is a tuple. The first item here is mapped to the first item here, the second to the second, and so on. We can use tuple unpacking to separate the individual item. For first, last, in zip, first names, print, first, last. Let's run the program again. Great. What happens when the iterables are not of the same length? Let's add another item in first names, bill. The zip function considers the length of the shortest iterable. The remaining elements in any longer iterables will be totally ignored. Let's run the program again to see the output. Awesome. This shows the same output. Next, we have the all function. The all function returns true if all the items in the given iterables are true. If not, it returns false. The key point is understanding what evaluates to true or false. Non-zero numbers such as 1 and 2 are considered true. A non-empty string evaluates to true. Non-empty containers like dictionary, lists, tuples, and similar data structures are also considered true. Let's run this program to see the output. Great, the output is true because all the items in the iterable are true. If I decide to put an empty string, the output is going to be false. Let's run the program again. The output is false. Moving on, we have the any function. The any function returns true if any element of an iterable is true. If not, it returns false. In this example, the final output is going to be true because at least one of the items is true. Let's execute the program to see the output. The output is true. Let's update the list to contain items evaluating to false. An empty string. In this case, the output will be false because there is no true value in the list. Let's run the program again. The output is false. Let me show you a practical use case. Suppose you are building an application to restrict users based on certain permissions. You want to check if the user has any of the required permissions. Required permissions is a list which looks like this. The retrieved user permission is also a list which may look like this. So you want to check if the user has any of the permissions required. To do that, you want to say that for each permission in the user permissions, is that permission present in the required permission? This is going to return true or false. The final output of this line will look similar to this. If the any function returns true, then we are sure that the user has one of the required permissions. The absolute value of a number refers to the positive distance between the number and 0. For negative numbers, the ABS value is the positive number. For positive numbers, it is the same number. The argument passed to the ABS function can be an integer, a float, or a custom object we create. Essentially, any object that supports ABS function must implement this special dunder method. Let's run the program to see the output. The absolute value of minus 10 is 10, while the absolute value of 22.3 is the same number. Let's use a string data type to see what happens. Python raised a type error, bad operand type for ABS function. This is because the _ABS function is not implemented on a string object. Let's create our own custom class which implements the dunder method. Now let's define this special method ABS def ABS self return 5. Let's create an instance ABS value of the object, which is the instance of the class. Print ABS value. Let's comment out this other part of the code. Now let's run the program to see the output. Great. As you can see, we are able to use the ABS function on our own custom object because we have defined this special method. The bool function returns true if the value passed to it evaluates to true, and it returns false if the value passed to it evaluates to false. It is important to know what evaluates to true or false. Y is an empty container. Let's run the program to see the outputs. They are all false. Now let's update the value of x1, a non-empty container, and a non-empty string. All the variables now evaluate to true. Can the bool function be used with a custom object, just as we did for the absolute function? The answer is yes. A custom object passed to bool will always return true because it is a real object. If you want it to return something different, you need to implement the bool dunder method. To fully understand these two functions, you need to understand what iterables and iterators mean. Any object that you can perform a loop operation on it is an iterable. Examples of iterable include string, list, tuple, and a dictionary. So it is possible for us to write for each in my string, this part of the code should be executed. For each in my string, print each. So let's run this program to see the output. Great, we're able to iterate over these string objects. Let's change this variable to a number, 256. Let's run the program to see what happens. As you can see, Python raised an error, type error. Int object is not iterable. On the other hand, any object that implements these two special methods is called an iterator. These methods allow the object to produce its elements one at a time. You use the iter method to turn an object to an iterator. The next function returns the next value in the iterator. Let's declare a list of numbers. My list 1, 2 equals. We want to turn this list into an iterator. We pass in the list, my list. We can now make use of the next function to return the next element in the iterator. Let's print this to the terminal. Let's run the program to see the output. We turned the iterable into an iterator using the iter function. Then we use the next function on the iterator to return the next element. The next function returns 1, which is the first element. Let's return the rest of the elements by using next again. We just need to keep calling the next function to return the next element, but it raises a stop iteration error when there is no more element in the iterator. Let's call the next function again. As you can see, a stop iteration error is returned. A workaround for this is to provide a default value to be returned when nothing is left in the iterator. Let's provide a default value of none. Let's execute the program again. Great. Alright friends, this is a custom implementation of the range function. The range function is used to return a sequence of numbers from a start to a specified stop. For instance, range of 0 to 5 returns all numbers from 0 to 4. The last value, which is 5, is excluded. The init method specifies that when an instance of this class is to be created, we need to pass the start and the end value. Immediately after that, we set the current position to be the start and the end to be the second value provided. The first check in the next method is to ensure that the current position is not equal or greater than the stop. For the first iteration, the next function will return the start value as the current. For the purpose of the second iteration, the current would be the next following number, and that is why we increment it by 1. In this example, the first number returned is 2, which is the starting position, We returned it on line 82. We immediately set the current value to be 3 for the purpose of the next iteration. For number in my range, print number. Let's run the program. Great. 2, 3, 4. The globals function returns all the global variables in the program. Variables defined outside of functions are said to have a global scope. This means they are accessible from any place in the program. Let's call the globals function to return all the global variables available. We are able to find the mylist variable declared as part of the dictionary returned. Notice that this variable, which was defined inside a function, could not be found because it is a local variable. Variables defined inside a function are said to have a local scope. When you call the locus function inside of a function, it returns the local variables available up to the point where you call the locus function. Let's call the sample function so that the locus function is automatically called. Sample function call. Let's execute the program. As you can see, it returns the local variable declared. The sorted function sorts the items in an iterable and returns it as a list. Sorted numbers equals, then the iterable we intend to sort numbers. Print sorted numbers. Let's execute the program. The numbers in the list are now sorted. The sorted function accepts an optional parameter which is reverse. Reverse specifies whether items should be returned in ascending order or descending order. The default is to sort in ascending order, which is why the default value of reverse is false. Now let's make reverse to be true so that we can sort in descending order. Let's execute the program. Great! The numbers are now in descending order. The reversed function accepts an iterable and returns a reversed version. When you pass an iterable to reversed, the last element becomes the first, the second to last becomes the second, and so on. Note that the reversed function does not perform sorting. It only reverses the elements of the iterable. Let's execute this program to see the output. As you can see, the reverse returns an iterator. To turn this into a list, we can use the list function. Now let's execute the program. Great, the numbers have been reversed. We've been using list as an example. We can also use any other iterable, such as a string data type. Let's execute the program. The output should be CBA in a list. Moving on, we have the map function. The first argument you pass to the map function is a function. The second argument is an iterable. The map function calls this function for each item in the iterable. Let's take a look at this example. We defined a function called square, which returns the square of any given number. It means for each item in numbers, we want to execute this function. The final result is now converted to a list. This is one way of getting the squares of all the numbers. Let's execute the program. As we can see, we have the squares of the numbers. For each number in numbers, this function should be called. We converted the result to a list because the map function returns an iterator. Similar to the map function, the filter function takes the first argument as a function. You use it when you need to extract or select specific data from the original data set based on a condition. Let's say we have a list of numbers and we need to filter out numbers that are greater than 4. We've defined a function which tells us if a number is greater than 4 or not. This function returns true or false. For each item in my list, this function is called. The filter function will return items for which the passed function returns true. In this case, a number is included in the final output only if this condition is true. This is how we can retrieve numbers that are greater than 4. Let's execute the program to see the output. Great, we've been able to filter out items that are greater than 4. The next function on my list is open. The open function returns a file object, which is essential for working with files. Whether you are reading from or writing to a file, this function is necessary. Suppose I have a list of courses and I need to write them into a file. First thing to do is to mention the name or path of the file you want to create. File path equals, I'm just going to call it courses.txt. Courses.txt. Next is to create a file object using the open function. File equals the open function. The first argument you need to pass is the file path, then the mode. W stands for writing. For each course, in my courses, file.write, we want to write the course plus a line break. Finally, we need to close the file, file.close. We open the file on this line, then we run a for loop on the courses. That is, for each course in my courses, the course should be written to the file. Print file saved. Let's execute the program to see what happens. File saved. Now let's go and check the current directory to see if the file has been saved. As you can see, we have a file created. The name of the file is courses.txt and this is the contents. A cleaner and more memory efficient approach is to use a context manager with the with keyword in Python. Let's comment out this part of the code. Let's use a new file name, courses2. Now let's run the program to see the output. This shows a new file has been successfully created. Let's open the file in read mode with open the file path as file for line in file print line dot argstrip. For each line in the file, we want to print out the content of the line. File path is referring to courses2.txt. Now let's execute the program to see the output. Great, this is how we can read the content of the file when the mode is read. In object-oriented programming, a child class is able to access all attributes and methods defined in the parent class. The cat class is a child class because it inherits from the animal class. As you can see, the cat class overrides the move method defined in the parent class. You use the super function when you need to call a method from the parent class. The super function returns a temporary object of the superclass that then allows you to call that superclass method. Cat_1 is an instance of the cat class. Then we call the move method on it. Let's run this program to see what happens. Animal is moving is printed out because we've used the super function to call a method in the parent class. If it turns out that a child class inherits from multiple parents and the move method is defined in all the parents, which move method would be called when we use super? Python uses method resolution order to know which method to call. Methods are searched from the left to the right. So the expected output here when the move method is called is parent2move. This is because the methods are searched from the left to the right. Let's execute this program to see the output. Great, parent2move, child move. The only point it goes to the next class to look for a method is when it cannot be found in the first class. Let's bring parent1 method to be the first. Now if we run the program, this method is called. Let's run the program. Great, parent1move. You use the double_MRO attributes on a class to examine its method resolution order. Child1 class dot MRO. Let's print this to the terminal. Print. This shows the method resolution order. Parent1 comes first. Let's change the order. Parent2. Now let's execute the program again. Great, parent2 comes first because of the order. A method is a function defined within a class. This it method is an instance method. Through the self parameter, instance methods can freely access attributes and other methods on the same object. This gives them a lot of power when it comes to modifying an object state. A class method takes the first parameter as CLS, which points to the class. It can work directly on the class without any need to create an instance of the class. @class decorator is used to flag it as a class method. On this line, we are calling the class method. Remember that we need to pass the new group argument as defined here. We are using this method to modify a class attribute, which is group. This group is pointing to this class attribute. To confirm that the group has been modified by this modify group method, we create an instance of cat so that group can be printed to the terminal. Let's execute the program. Great, group is wild. That's because we've used the class method to modify a class attribute. Static methods take neither self nor CLS as the parameter. This means a static method cannot modify object states or class states. They are mostly used as utility functions in programs. For instance, this static method is doing some computation before returning the current time. Current time equals, let's execute the program. This shows the value returned by the method. The callable function returns true if an object appears callable. If the object is not callable, it returns false. The term callable means that you can use double parentheses immediately after the object to call it. We've declared two variables, a string data type. the second variable is pointing to a function we've defined. Let's use the callable function to know if we can call the two variables. Let's try out y, which is pointing to a function. The output is true. This shows that we can call y, which is pointing to a function. Let's see if x is callable. X is a string data type. Let's run the program again. X is not callable. The implication of this is that if we try to call x, Python is going to raise an error because it is not callable. Let's try that out. Python raised a type error. String object is not callable. Instances of a class are callable if the class has this special call method. Let's call an instance of this class cat1. Let's execute the program. Cat object, which is an instance, is not callable. The double underscore method is required for an object to be callable. Let's declare the method in the cat class. Def call self return. We can specify what we want it to be returned when it is called. Now we can easily call the cat object. Let's call it. This shows there is no error. Let's print out something to the terminal. Print. This works. The range function can be used to return a sequence of numbers. Suppose you want to get a sequence of numbers from 1 to 10. You can simply use the range function. The first argument is the start, while the second is the end. Let's print out the numbers. A range object is returned. You can use the list function to convert the range to a list. Alright, so let's execute the program again. Notice that the stop value is excluded. Another way to retrieve the numbers in the range function is to use looping. For each in range 1 to 10 point. Let's execute this program. This is how we can use looping to retrieve the numbers. If the starting position is not given, then a default value of 0 is used. Let's remove the starting position. The expected output should start from 0. Let's execute the program again. The third optional argument that can be passed to the range function is the step. If you specify 1, which is the default step, we get the same result. Let's run the program. Now let's specify 2. Now let's execute the program to see the output. 1, 3, 5, 7, 9. So every second number is returned. Suppose we need to obtain every odd number from 1 to 20. We can use the range function to achieve this. 1 to 20. The step should be 2 so that every second number is returned. Let's convert the range to a list. We can now print out the output. Print. Let's execute the program to see the output. 1, 3, 5, 7, 9. We have been able to retrieve every odd number from 1 to 20. The len function returns the number of items in an object. Given a list, we can use the len function to know the total number of items present. Len languages. Let's print the output to the terminal. Print. Now let's run the program. The argument passed to the len function may be a sequence or a collection. The sum function returns the summation of numbers present in an iterable. Suppose we have a list of numbers and we need to calculate their sum. We just need to use the sum function. Result equals sum. Then the iterable numbers. Print result. 10 is returned as the summation of the numbers. If the iterable is empty, such as an empty list, the result is 0. Let's run the program again. Great. When calling the sum function, you can pass an optional start value to it. This start value will serve as the first element. If the list provided is empty, this start value will be returned. Let's specify the start value to be 1. Now let's run the program to see the output. Great. Given an iterable, max returns the largest item while min returns the smallest item. The maximum value is 9 while the minimum value is 2. These two functions are not limited to numbers alone. Items in the iterable can also be strings. Let's try that out. My underscore string equals a list of strings. Let's execute the program. The maximum is C while the minimum is A. The hasattr function, short for has attributes, checks if an object possesses the attribute specified by the name. It returns true if the attribute is present and false otherwise. Group is a class attribute, while name and age are instance attributes. On this line, we create an instance of the cat class. These two arguments are passed as declared in the init method. So we want to know if cat_1 has name attribute, age attribute, and group. This shows the cat_1 object has all the 3 attributes. Group is true because instance of a class has access to the class attribute. Let's specify an attribute that doesn't exist. Cat level. So we need to specify the attribute here. Let's run the program again. This shows that the cat does not have an attribute known as the level. The setAttribute function sets the value of the attribute of an object. Let's set the attribute of level, which does not exist. So the first parameter we need to pass is the object cat1, followed by the attribute we want to set, level. Then the value of the attribute we want to set. Let's set the level to be 10. The previous result for hasattr for level was false. Now let's check the level after we've used setAttribute to set the attribute of level. As you can see, the hasattr function is now showing that level exists. The getAttribute function returns the value of the named attribute of an object. Let's get the value of name. Name value equals getAttributes. We need to specify the object cat_1. Then the name of the attribute we want to get its value, name. Print name value. Let's execute the program. This shows that the value of attribute name is node. The isinstance function returns true if the object argument is an instance or subclass of the class info argument. Suppose you have a variable and you need to know if it's a list data type or not. List equals the isinstance function is instance my list, which is the object, then the class info list. Is this list object an instance of a list? Point is list. Let's execute the program. The result is true. This means this list object is an instance of a list data type. Let's check if the variable is a string data type. Is string str of a string? Point is string. Is my list, which is a list data type, an instance of a string data type? Let's execute the program to see the output. The output is false because my list is not an instance of a string. You use the issubclass function to check if a class is a subclass of another class. It returns true if this class is a subclass of this class. We have two parent classes, parent1 and parent2. Child1 is a subclass of parent1 because it inherits from parent1. Let's make use of the issubclass function. Result equals issubclass child1 parent1. Is child1 a subclass of parent1? The result is true. Let's run the program. A subclass of parent2, the result is false. This is how we can use issubclass function to check if a class is a subclass of another class. The next function is id. The id function returns the identity of an object. Whenever you declare a variable such as x equals 5, an object is created in the computer memory. X is just a name pointing to that object. Each object in the computer memory has a memory address unique to it. The memory address for such object is returned by the id function. Let's make use of the id function. id of y. Let's print out the result. Print. Let's execute the program. This shows the id of the object. When you write sum_value, which is a new variable entirely, equals x plus y, a new object is created and its value will be the sum of x and y. id sum value. Let's execute the program and see the output. Great. A fronzenset is similar to a regular set in Python. However, a fronzenset is immutable. Immutable means that its items cannot be changed once it is declared. Sets are known for containing unique items and offering constant time retrieval of elements. Let's try to add an element to a fronzenset. cities.add new. Let's execute the program. Attribute error. Fronzenset object has no attribute add. This is because you cannot modify a fronzenset. Adding an element works fine for a regular set, which is mutable. Regular set.add new. Now let's point out the content of regular set. This shows that a new item has been added to the set. The round function rounds a number to the nearest whole number. If the value after the decimal is less than 5, it rounds to the same whole number. If it is greater than 5, it rounds up to the nearest whole number. Let's execute the program to see the outputs. The first number rounds to the same number, while this rounds up to the nearest whole number. The default behavior of the round function is to round to the nearest whole number, but you can optionally specify the number of decimal places to be considered. So let's specify one decimal place. The number after the first decimal place is greater than 5. The result here will be 22.8. Let's execute the program. Great, 20.4, 22.8. The round function shows unexpected behavior when the digits in the decimal part ends with 5. What do you think the output would be for num1 and num2? You might expect num1 to be 7 and num2 to be 8. Let's execute the program and see the output. Surprisingly, num1 runs down while num2 runs up. This is because Python 3 and some other programming languages adopt a strategy known as round ties to even. A tie is a floating point number ending with 5. If the digit to the left of the last digit in a tie is even, it runs down to the same number. If the digit is an odd number, it runs up to the nearest whole number. This is why 7.5 is 8. A property is an attribute that is computed dynamically. Suppose we need to tell each user his full name. There are numerous different approaches this could be achieved. First, we may decide to add a third instance attribute. So we can write self.fullname, which is a new instance attribute, equals self.firstname last name. Now I'm going to show you why this approach is not the best. Let's print out person1 full name. Print person1 dot full name. Let's run the program. Great, this shows the full name of the user. On the next line, let's change person1 first name. person1 dot first name equals a new name. Let's call it Alish. Let's print the full name again after the first name has been modified. Let's run the program. As you can see, this shows the full name is not returning the correct data. The value of the first name has been modified, but it is not reflecting in the full name. Why is this happening? This is because the constructor method, which is setting the value of full name, is called once when a class is instantiated. So it is unaware of what is happening after an object is created. The second approach to get a full name is to use a method. Every time this method is called, it returns the full name based on the current first name and last name. Let's try to define a custom method to achieve this. Let's name the method getFullName. Def getFullName. The first parameter should be self, pointing to the instance. Return f-strings self.firstname self.lastname. Let's remove this third attribute since we are using a method now. person1.getFullName. We are calling the method on this line. Then person1.getFullName again. Let's execute the program. The getFullName method works fine. Changes are now reflecting in the full name after the person's first name has been modified. The Pythonic solution to this problem of computing an attribute dynamically is to use property. You just need to decorate this method with @property. Let's comment out the first one. Now you need to decorate this method with @property. It would make sense to rename this method so that it resembles an attribute. Let's call it full name. We can now make use of it as an attribute. person1.fullname. Let's execute the program again to see the output works fine. Be sure to check out the upcoming lesson on object-oriented programming, where we dive deeper into getters and setters. You might want to check what *asks and *works do in a Python function. Like, comment, and share. Thanks.